Uh, I think it has been started. I am going to teach you about the motion and standard is ninth. About it in details, I will be sharing all information regarding this, whatever will be important in standard of ninth class. Name of the chapter is motion, and my name is written here. My name is written here. Uh, in this slide, you are observing that name of this lecture is going to be motion, and standard is ninth. Clear? So let's start. Let's start. Key concept in motion. Now, let's start from a scratch. From meaning of rest and motion. Object is in motion. Object is in rest. What are you thinking about it? I am saying that object is in rest. You would say if object is in rest, it means time is passing. Time is passing. Time is passing, but object is still in rest. But object is still in a rest, and you can say it is a standard mode. It would be standard mode, meaning to define object is in a rest. Always remember, if object is in rest, it means time is passing. Time is passing, and that object which is in rest is not moving at all, is not covering distance at all. Clear? Now, uh, what about those objects which are in motion, which will be in motion? What about those objects? So remember, I said there are a lot of objects which are in rest, but on the other side there are also a lot of objects which are in motion. Now, when it comes to motion, a object is in motion. Then always remember, always observe what a object will be moving, then of course at the same time that object will be covering distance, and one more, that object will be taking time. Okay, it can be long time, it can be short time. Clear? So object is moving, it means that object is taking time. Clear? As well as you can say that object is covering distance. Now, if we are saying a object is a covering distance, it means that object is moving. Of course, that's why that object is taking time, as well as that is covering distance. All these three will happen when a object will move from one place to another place. Then all this what, a object will take time, a object will cover distance. Okay, all this will happen when a object will move from one place to another place. And a object will move from one place to another place when objects will force will be applied. Then it will be possible that object will move from one place to another place. But in this slide, in this lecture, we are not understanding, our main focus is not on forces. It was a little information regarding force. I i uh, i took what force word because of here object will move when external force will be applied, then object will move. Clear? You can apply, if a object is in rest, then of course we are not applying force. That's why object is in a rest. Object is in a rest. Clear? So this was a basic explanation of this lecture. Now here key concepts in motion. Key concept, it means important concepts in motion. Motion, when an object changes its position, it means it is telling you when a object will travel from one place to another, then what will happen? It will travel with the time. If object moves, then of course time will change, time will be covered. So when an object changes its position with the time is the definition of motion. Types of motion. There are two types of motion. First is uniform motion and second is non-uniform motion. Both are compulsory to understand. Here, uniform motion. Uniform, which means same. Same, okay. Uniform, which means same. Same. Now, what is the meaning of a uniform in motion chapter? What is the meaning of a uniform in motion chapter? It is telling you a object will be moving. We are understanding what motion. Motion. Motion, which means a object is moving. Object will be moving. Object moved. Like that we are trying to say as a lecture. As a lecture of it. Now here motion will be uniform. If an object is moving, it means that object will be moving with us as with a constant speed, with the same speed. It is the meaning of a uniform motion. Motion is uniform. A speed is uniform. A speed is constant. A speed is fixed. It is the meaning of a uniform motion. Equal distance in equal time travels. It is telling you if a vehicle is traveling, a vehicle is covering a 1 kilometer distance within a 20 minutes. So again that vehicle will cover how much? Same distance, 1 kilometer, and time will be same. Time will be same, 20 minutes. This is the meaning of a uniform motion. Here you are observing with this example that distance is equal after completing 1 kilometer distance within a 20 minutes, and this is happening again and it will be happening again. Then this type of motion of the vehicle will be considered as a uniform motion. Remember. Clear? Okay. Object, whether it is a vehicle, whether it is a object, anything which is moving and a speed of that is a speed of that object is uniform or same or constant, so motion of that object will be considered as uniform motion. That's it. If something is changing, for example, this same vehicle is covering how much? 1 kilometer distance, okay, within a 20 minutes. Now again, uh, distance is the same. That vehicle is covering same distance, but now that vehicle took how much time? 25-minute times. Let's assume that vehicle took 25-minute times to cover 1 kilometer distance. Initially, in the first case, that vehicle took how much? 20 minutes. Now that vehicle took how much? 25 minutes. So here time is changing. We can see what sometimes we will see that distance is changing. Sometimes we will observe what time is changing. In that case, uh, this type of motion we will consider as non-uniform motion. Okay, non-uniform motion. If distance is changing and time is the same, then we will consider what? Non-uniform motion. If time is changing, distance is equal, distance is the same, then again we will consider that motion as a non-uniform motion. Always remember. If nothing is changing, distance is also equal, time is also equal after completing one what 1 kilometer. Okay, clear? that type of motion we will consider as a uniform motion. That's it. In this slide we had to understand about meaning of a definition, about types of motion we have completed with example. Now I am moving forward. Important terms. Important terms. Distance, which is measured in meter. It can be also what, kilometer. Kilometer is for long distance. Meter is for shorter distance. Okay, and both are used to apply. Both are used to measure distance. Clear? When it will come to meter, then we will understand that yes, it is for shortest distance. It is for a small distance. Meter is for a small distance. But when it will come to kilometer, then we will have to understand that yes, it is for long distance. Clear? It is for long distance. So distance, total path covered, it is a scalar quantity because it has a only magnitude, uh, not a direction. That's why it was considered as a scalar quantity. So distance, which means total path covered, and displacement. Displacement, it will say that definition of displacement will be what? Will be shortest distance. It will not say that you are going this that. No, you will have to go from one place to another place, which should be in a straight direction, not a zigzag. Okay, not zigzag, only in a straight direction. If you are covering a if you are calculating a distance which is in a straight direction, will be considered as a displacement. Displacement is also distance, but it will not take total length. It will take only shortest distance which will be in straight direction. Clear? Otherwise you can understand it by saying, if a object was moving, and that object covered some distance. Now displacement, how to calculate the displacement, this is question. Clear? So here you don't calculate like this. If you are thinking that yes, this object covered from here to till here 5 kilometer distance, again 5 kilometer distance, not like this, not like this. Clear? Not like this. Only shorter distance. For example, a vehicle is here, and it started moving, and it is stopped here. So this from here to till here is what? Shortest distance. It is also distance, but it will be also considered as a displacement, because from here to till here is also displacement. Now vehicle is here, and it is going like this, like this, like this, like this, like this. So you will calculate total distance, this covered distance, like this. But when it will come to displacement, then just assume that from here to till here, what is the distance, and that distance is a displacement. That's it. Clear? And distance is considered as a scalar quantity because of it has only magnitude. A scalar quantity, which means a quantity which has a magnitude, then that quantity will be considered as a scalar quantity. Now displacement is not a scalar quantity because it has what, magnitude as well as direction. That's why it is considered, rather than considering it as a scalar quantity, it is considered as a vector quantities. Vector quantities are those quantities which have magnitude as well as direction. Okay, when you are calculating displacement, then you will have to indicate a direction. Then you are going to prove that yes, it is a displacement. Clear? Shortest path between initial and final position. Initial which means starting point, final which means end point. Clear? Speed. This is a formula distance upon time. If you want to calculate what is the distance, what is the speed of something, then you will have to use this formula, which is the distance upon time, and it is considered as a scalar quantity. If you want to know how did it come, then I would say here we are finding what a speed, with how much speed your vehicle covered this much distance. This is what we are trying to understand from this formula. If you want to know what is the distance, if a speed is this much, time is this much, then this will not be formula, but from this formula find you can find how to calculate complete distance. And for distance formula would be what? Speed multiple time. Speed multiple time. But to identify time, then speed upon time. No, speed upon distance. Okay, is equal to time. Now here, I said you a speed which tells what is the speed of a vehicle. A speed is a moving slow or fast. We will tell this a speedometer, a speed which is found in vehicle, and in vehicle you will find what? You will observe a speedometer device, and a speedometer is a device which is used to find what is the speed of my vehicle, what is the speed of your vehicle. Okay, and in a speedometer device you will get what? A speed of your vehicle. Okay, with this much of speed your vehicle is moving. Clear? And it is a scalar quantity because of it has magnitude. Now if I am saying that a speed is a scalar quantity, so you are already clear that yes, if it is a scalar quantity, it means it has a magnitude. It has a magnitude, but how to prove it? How to prove that it has magnitude, it is a scalar quantity? How to prove? This is question. Okay, this is question. Let's prove here a speed. We are saying what? Only we need to identify what is a speed of vehicle. Only we are finding a speed, not a direction. We are not finding direction. A speed will give you only slow slowest or fastest. It will tell you only a speed. Fastness, it will tell you fastness of something. That's it, nothing else. Okay, nothing else. So here I was telling you about speed. A speed will explain what is a fastness of something. It That's it about a speed. Okay. Now it is a scalar quantity. We have to prove it. uh, I told you it tells only as fastness. It will not tell a direction of something, of a vehicle. That's why it is a scalar quantity. And here, what is the definition of a scalar quantity? It has only a scalar quantity are those quantities which have only magnitude. When it comes to magnitude, it means only number with a unit. Only number with a unit is a scalar quantity. When we involve when we apply direction, then that quantity is known as a vector quantity. Clear? So next velocity is also a speed. Velocity is also a speed. But in the case of, in the definition of a speed, I was telling you that it has only magnitude. But in the case of velocity, here you will observe what? It has magnitude with a direction. And that's why it was considered as a vector, and it is considered has vector quantity because of it has magnitude with direction. That's why. This is the difference between a speed and velocity. A speed does not have what direction. Velocity has a direction with magnitude, and work of both is the same, but a little is a difference. What velocity will tell you direction, what is the direction of your vehicle, what is the speed of your vehicle with in which direction. This is what velocity will tell you. Clear? And both looks similar, but a little difference is there, is that what just a direction. A speed does not have a direction, velocity has a what direction. That's. And here always remember, as we said that displacement is a vector, so same here, displacement is coming, and to identify velocity, displacement will come. In the case of calculating speed, then this distance we will involve here. Distance is a scalar. Now displacement, distance and displacement both looks similar, but as I told you, there is a little difference, is that distance has a only magnitude and displacement as a direction with the magnitude. This is a little difference between them. So to calculate velocity is formula is that displacement upon time. Clear? Displacement upon time. Clear? Acceleration, change in velocity upon time. Here, before we understand what is a formula of acceleration in detail, let's understand what is the meaning of acceleration. And it is very interesting to understand the meaning of acceleration. It will tell you what is a change of velocity. What is a change in velocity? It means a vehicle is covering distance, a vehicle is moving, okay, so that vehicle will be moving with constant speed, but all the time that vehicle will not be moving with constant speed. Sometimes that vehicle will be applying less speed, sometimes more speed. This is what will happen. It is happening in our daily life, isn't it? Sometimes we need to apply less speed, we need to apply more speed. Clear? Now here we are saying velocity. Okay. So what is the meaning of acceleration? Acceleration, which means increasing. A speed is increasing or decreasing, is a meaning of acceleration. What is the change of velocity in time? What is the change in velocity? Is acceleration. Time is increasing. A speed is increasing. Speed is not fixed. Is a acceleration. A speed is not. A speed is increasing. Sometimes it has a speed of 20 meter per second. Sometimes 50 meter per second. So it is the meaning of acceleration. Here we are observing what there is a change in a speed. There is a change in velocity. Clear? Now time will come, yes, because of we are understanding motion. Here acceleration is what? Acceleration is motion. Something is moving, then we will be able to identify what is the acceleration of that moving object. This will happen when object will be moving. Okay, that's why time will come. Change in velocity. So first we will take what? Final position, then we will take initial position. Final position minus initial position upon time is the formula of acceleration. Clear? U minus v details. Someday we will be exploring about all this formula, speed, velocity, acceleration in details. Okay, now again I would like to explain, I would like to repeat it. Okay, again, speed is also what something is moving. It explains what is the fastness of a something is a speed. It will tell you magnitude only. It will not explain what is the direction of this moving object. No. Okay, that's why it was considered separately from velocity. If a object is moving with some speed, will be considered as a speed. Now, if a object is moving, but that object is moving in direction, then that object will motion of that object will be considered as a velocity. Clear? What is the acceleration? Acceleration, which means time is increasing. Time is unknown. Time is increasing. No. A speed, velocity. What is a change in velocity? If a velocity is increasing, it can decrease, it can increase. That's why it was considered something else, and that was what acceleration. Acceleration. Clear? Okay. If it is clear, next slide. Graphical representation through graphical how to understand this lecture, how to understand those points that we explained. Okay, first is a distance. Make a graph like this. Clear? And straight line, which means straight line in graph. If there is a straight line like this, then we would say what? Like this, then we would say motion is what? Uniform. If there is a curved line in graph, we would say motion is a non-uniform motion, because of a line is a curved line will tell you motion is a non-uniform motion, but straight line will tell you motion is what? Uniform motion. Velocity time graph, area under the graph is equal to displacement. About it we will understand later. Equation of motion. These are used when acceleration is a constant. It means time distance is not changing. Distance is fixed. Then this will be used. V is equal to u plus at. V is what? V is final velocity. uv. So u will be initial velocity. V is a final velocity. Clear? So first letter is coming what? U. That's why we will say it is an initial velocity, and then next letter is coming, which is V. We will consider it as a final velocity. Here V is equal to, this is a formula to identify, to calculate what is a final velocity. What is a final velocity? Then you will, if you want to calculate final velocity, then this just use this formula u, which means initial velocity, plus at. A is acceleration, t is a time. And all this came from acceleration. Acceleration. A is equal to what? A is equal to what? A is equal to V minus U upon T, and from this formula this came, V is equal to U plus AT. And how to identify a speed? Then just use this formula. S is equal to UT plus 1 upon 2 AT square. Okay. And next is uh, velocity velocity raised to power 2 is equal to u square, b square is equal to u square plus 2a. A is acceleration, s is a speed, s is a speed. So here u will be represented as an initial velocity, v will be represented as a final velocity, a is acceleration, t is the time, and s is not a speed, s is a displacement. Clear? S will be represented as displacement in solving question in a numericals. Clear? In a numericals. So this were formula, and in separate lecture I will explain all this with proof. How did it come? Okay, how did it come in details? I will explain it in details in separate lecture. Now, uniform circular motion. Now here you can see we have understood meaning of uniform motion. I am not saying uniform circular motion, only uniform motion we have understood. Now here one word is added with this, is what? Circular. It means circular looks like this. Circle looks like a circle. So here a object is moving in circle like this, and if a object is moving in circle shape, this type of motion, here a object moving, and this type of motion will be considered as uniform circular motion. And one word is that what? Uniform. It means motion. A speed of motion is a fixed. A speed of moving object is fixed. That's why, and it is moving in circular shape. That's why this type of motion will be considered as uniform circular motion. Remember, a object is moving in circular shape with a fixed speed. With a fixed speed will be considered as a uniform circular motion. Motion in a circular at constant speed. Clear? Velocity changes due to change in direction. Now from here you can understand non-uniform circular motion. Remember, if a object is moving in circle shape, and here a speed is not fixed, a speed is increasing, decreasing, so that type of motion will be considered as a non-uniform circular motion. Clear? Now acceleration is directed towards the center. Now meaning of this is what? This is circle, a object is moving like this. It means acceleration is directed from center to the circular shape like this. Clear? In details, this type of motion is also considered as a centripetal. I am not talking about this a circular motion. This is a circle, as you can see. This is a circle, and on this circle, on outline, on the circumference of this circle is moving a object, and a object is moving like this. As speed of this moving object is changing, then we will consider this type of motion as a non-uniform circular motion. If speed of this moving object is constant, then this type of motion we will consider as a uniform circular motion. Now we are understanding what? Here center is here, and this object is here. So acceleration will be directed to this center, and this direct arrow direction will be this will be direction. Clear? And details we will understand in separate lecture about the centripetal motion, and it is also taught in gravitational chapter. I am moving next is motion. We have some objective questions of this lecture. We have some objective questions of this lecture. First is what is a motion? What is a motion? Clear? So I can say that these are questions for you, but no. Let's answer all this question together. What is motion? A object is moving will be taking time. A object is moving will be taking time is motion. Now define uniform motion. A object is moving. A object is covering distance, and a speed of moving object is fixed or constant or same. uh, that motion is a non-uniform motion. That motion is a uniform motion because of a speed, because of a distance is equal, because of time is equal. After covering 1 kilometer distance, again distance is the same, 1 kilometer, again 1 kilometer, and as well as time is the same. What let's say 1 kilometer is being covered within 20 minutes, then same again, or distance is the same, which is 1 kilometer, and 1 kilometer is being covered within 20 minutes. This is happening again and again, and this is a motion. A whole view is a motion, and this type of motion is what uniform motion, because of distance is equal, because of time is equal, that's why. Now next is non-uniform motion. Same here. If a distance is changing, time is same, then this type of motion we will consider as a non-uniform motion. Or time is changing, distance is same, then again we will consider this as a non-uniform motion. And both are changing, then still we will consider this type of motion as a non-uniform motion. That's it. This was a definition of a non-uniform motion. Next, what is the speed? What is the speed? Now, a speed explains how much speed a object is moving. With how much speed a object moving. A speed will tell you, yes, there are two objects, there are two vehicles, and one vehicle covered distance is fixed. Okay, distance is how much? 35 kilometer for both vehicles. Now, first vehicle both moved with the same time, with the exact time. Now, first vehicle covered 35 kilometer distance within 1 hour. Now, next B vehicle covered how much distance? Same, 35 kilometer. But time, that vehicle took time how much? 55 minutes. So now, from this, can you tell that which vehicle, a speed of which vehicle was fast? So you would say vehicle B, because of that vehicle took less time to cover the same distance, 35 kilometer. Okay, that is how you can tell a speed of something. Clear? Now, what is the SI unit of a speed? I think it should be meter per second. Meter per second. Now, next is what is the velocity? Velocity is a speed, but it has a direction. That's it. Okay. Now next is what is acceleration? Acceleration is what? It explains that yes, object is a speed of object is increasing, velocity of object is decreasing. So this motion will be considered as acceleration. Write the formula for average speed. Average speed. So I think average speed, total distance upon total time taken, total distance upon total time taken. Now next is write the formula of write the three equations of motion. As we saw, v is equal to u plus at, v is equal to u plus at, where v is final velocity, and u is v is a final velocity, u is initial velocity, a is acceleration, t is a time, s is a displacement. Now to identify displacement will be equal to, I don't know. Here you can see displacement. To identify, to calculate a displacement, we will use what ut plus 1 upon 2 at square. Clear? Now I am moving next toward right type of graph is obtained for uniform motion. So for uniform motion, graph will be look like this. Line will be straight. Line will be straight for uniform motion. For non-uniform motion, line will be curved line. Clear? Now answer is here. Answer is here. So as you can see here, the SI unit of speed is a meter per second. As I told you, motion is the change in position of an object with respect to time. It is a standard meaning from Hooke language. Uniform motion is when an object covers equal distance in equal time travel in equal interval of time. This is the meaning of a uniform motion. Again, I am telling you, it is a standard meaning, and if you are confusing that yes, it should not be meaning of uniform motion, then this is for you. It will give you proof. It will give you proof. It will give you confidence. Yes, it is a meaning. From your language, you can explain this. You can explain different from this, but meaning should be same. Explanation can be different, but meaning of word should be same. Okay, next, velocity is the speed of an object in a given direction. So when velocity will come, it means direction will come. Okay, velocity is the speed of an object, but in a given direction. Both looks similar, but velocity has a direction, and a speed has only a magnitude one. Acceleration is the rate of a change of velocity with respect to time. Acceleration, it means a speed of a object is increasing. Sometimes it is decreasing, and it is also taking what direction. It can take a direction. Of course, it is moving. Of course, it will take what a time. So to calculate acceleration is equal to what change in velocity upon time. That's it. Average speed is equal to total distance traveled, okay, upon total time taken. Here average speed, okay, clear. We have three equations of motion. For calculating final speed, we have what u plus at. For calculating displacement, we have ut plus 1 upon 2 into a t square. For velocity, for v square, which is what it is what final velocity. Clear? For final velocity square is equal to u square plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, t is the time, s is the displacement. Okay, rather than writing a complete word, we can write only a letter. V is represented as final velocity, u is represented as initial velocity, a is represented as acceleration, t is represented as a time, s is being represented as a displacement. A straight line graph is obtained for uniform motion. That's it. We have completed. So yes, that's all in this slide about motion. We will in next lecture we will be taking next chapter. Okay, next lecture, which name would be something else. So that's all in this slide.